Hello children, in this class we are going to discuss the numericals based on exercise 2a. So in a previous classes we might have discussed about some theory part, but particularly in this session we are going to solve numericals. Total 16 numericals are there children. So we will solve each and every numerical so that you feel very comfort. Okay children, let us start. So children, before going to solve the numericals, we need to understand the relation between kilometer per hour to meter per second. So first let us see that actually. Children here, look at here, 1 kilometer per hour is equal to how many meter per second? This is a very important to understand so that we can solve the numericals easily. I mean conversions will become very easy. So children, we know that 1 kilometer is equal to 1000 meters. Am I right? Yes. And 1 meter can be written as even 1 by 1000 kilometers. Okay, na? That is fine. And also we know that 1 hour is equal to 3600 seconds. Now these two values let us substitute here. So here we will get 1 kilometer per hour is equal to, so in the place of kilometer we can write 1000 meters, whereas in the place of 1 hour we can write 3600 seconds. Let us simplify this. 2 zeros, 2 zeros, 2 fives are 2 18s are. So which means what children? 1 kilometer per hour is equal to 5 by 18 meter per second. This is very important relation. This relation we use to convert kilometer per hour to meter per second. Then how to convert meter per second to kilometer per hour? Look at here. 1 meter per second is equal to, get this 5 by 18 this side, so it will become reciprocal, that is this will become 18 by 5 kilometer per hour. So children, these two relations are very important to solve the numericals. I mean wherever it is needed we can use it. First you copy this so that we will start a first numerical. So numerical 1, it is given that a car is going with 72 kilometer per hour. They are asking us to express in terms of meter per second. So children, just now we got a relation, that is 1 kilometer per hour is equal to 5 by 18 meter per second. So this value substitute here. So V is equal to 72 into 5 by 18. So 18 ones are here, 18 fours are. 4 into 5 is how much? 20. So the speed of the car is 20 meter per second. So this is how we can solve. Okay, now fine. Now second numerical. So as per the question, let me just wait. So what the question is given? Second children. Yeah. Express 15 meter per second in a kilometer per hour. So it is given 15 meter per second. Now they are asking us to express in kilometer per hour. So we know that 1 meter per second is equal to 18 by 5 kilometer per hour. Now you substitute here. V is equal to 15 into 18 by 5. Children, 5 ones are 5 threes are. So V is equal to 18 threes are how much it is? 54 kilometer per hour. Is that clear? Fine. So in a third numerical, A1 is given 1 kilometer per hour and the B1 is given 18 kilometer per hour. So they are asking us to, sorry, second one is given kilometer per minute only. Children, you should be very careful this one. So we have to convert here. First one, look at here. So this can be written as 1 into 5 by 18. So 5 by 18, if you can simplify, you will get 0.278 meter per second. That's it. But second one we should be very careful. We cannot use a direct formula here. Direct value 1 kilometer per hour is equal. We can't use that. Why? Because it is given kilometer per minute. So here the simple way we can do like this. 18 into 1 kilometer is equal to 1000 meters children. 1 minute is equal to 60 seconds. You can use this. Now 0, 0 cancel. 3 2s are 3 6 are 2 1s are 2 3s are. So it is 3 into 100 is how much? 300. So which means what? 18 kilometer per minute is equal to 300 meter per second. Children, again I am telling you. So especially in this question, directly you cannot substitute value. Why? Because it is given kilometer per minute. So that we should understand very, very well. That's very important to understand. Okay, just copy it. So fourth question, it is given that children, here it is given 10 meter per second, first one is given, second one 1 kilometer per minute is given, third one is given 18 kilometer per hour. Now they are asking us to arrange in a increasing order, ascending order. I mean small value to big value. But the problem is that if these three are in the same units, then we can arrange easily. But if you can see here, it is in meter per second, it is kilometer per minute, kilometer per hour. Then what we have to do? First of all, we have to convert into any only single unit. So what we do is that let us convert all into only one units only. That is meter per second we will convert. Okay, let it be first one is meter per second only. So this one 18 into kilometer per hour is equal to what, children? 5 by 18 meter per second. So 18 cancel. So this value will be 5 meter per second. Now let us do this. So this is 1 kilometer. 1 kilometer means what is 1000 meters by 60 seconds. 0 cancel. Now 6 table, 6 ones are here also 6 1. So 4 is left. It is a 40. 16 point something you will get. Means this is again 6, let us say this is 16.6 meter per second. So this value is 10 only. Now if you can see, now you can keep in a order ma. So small value to big value we have to arrange. Small value is this one, next small value is this one, highest value is third one. So arrange 18 kilometer per hour, second one is 10 meter per second, third one is 1 kilometer per minute. Children, we arrange in an increasing order. Okay, just copy this. Numerical 5. It is given that a train takes 3 hours to travel from Agra to Delhi. Let us say it's Agra, it is Delhi. Children, don't think that Agra and Delhi are this much close. So just as a part of numerical we are showing. Okay, na? So it is given that it takes 3 hours time and with a 65 kilometer per hour. Now they are asking us to find or calculate the distance between the two cities. So children, we know that distance is equal to speed into time. That's it's very simple. Speed into time. Speed is 65. This is 3. So this will be 195 kilometers. So simple. Okay. So children, let us see what is given in the sixth question. First, let us see. It is given that this is 40 kilometer per hour. So which means what? Actually, if you can see in a case 1, A to B, let us divide into 2 equal parts. So A to B, it is given that first distance is 30 kilometer, so that the speed is 60 kilometer per hour. Let us calculate the time, children. So we know that here it is a speed is equal to distance by time. So time can be written as distance by speed. So with this it is clear that it is 30 by 60. So T1 is equal to 0.5. It is what we can say, we will get hours. Am I right? We will get in hours only. Okay, fine. Now in the second part, if you can see, so B2C, that is, so here let us say S2 is 30 kilometers, whereas V2 is given 40 kilometer per hour. So same formula let us apply here. Time is equal to S2 by V2, that is 30 by 40. If you can simplify this, children, you will get this is 0.75 hours. Now what they are asking, total time taken. So T1 value we got, T2 value we got. So T1 plus T2 also we can substitute. How much we will get? Let us calculate, check once. So let us convert it to minutes, children. 1 hour is equal to 60 seconds. So this will become 30 minutes. So this also 0.75 into 60 minutes. So we will get 45 minutes. So here first side it is a 30 minutes and 45 minutes. The total time is how much, children? Let us write here total time T1 plus T2, that is 30 plus 45. So this will be 75 minutes, that is 1 hour 15 minutes. 1 hour 15 minutes. So children, in the second part of the question they are asking us to calculate the total, or we can average speed. So we know that here average speed, my marker is not writing, average speed is equal to total distance traveled, children, total distance traveled by total time taken, So total distance is how much? 30 plus 30, it is going to be 60. So this is 60 by total time taken, it can be written as 1 hours, it can be written. So if you can simplify this, we'll get 48 kilometer per hour. 48 kilometer per hour. So children, to calculate the average speed, we must know the total time taken. So in a two parts, A to B we calculate the time taken, B to C we calculated, then we calculate the total time taken. From there only, this point only, we could calculate the average speed. So without knowing the total time taken, we cannot calculate. In exam, if they will ask total time taken or not, if they will ask us to calculate the average speed, we must calculate the total time taken. Is it clear? Copy it. So children, as per the question 7, look at a train. So the question is completely based on the train, means it is going from A to B, again it is coming back from B to A. So children, here let us say it is a point A, station A to station B, let us say. So when it is going station A to station B, it has taken 2 hours to reach, whereas from station B to station A, it takes 3 hours. In between A to B, the distance is 200 kilometers. 200 kilometers. Now they are asking us to calculate the average speed and average velocity. Children, as I told you that to calculate the average speed, we should have a total distance traveled, total time taken. So it's very simple, children. Here total distance is how much? Total distance, let us take a total distance. So A to B is a 200 kilometers, B to A also 200 kilometers. So this total will be 400 kilometers. Okay, na? Fine. Now we need to calculate the average speed. So let us calculate the first speed from A to B. So or else directly average speed will write. So children, here average speed is equal to, we know right directly, average speed is equal to, let us say the S, total distance traveled by total time taken. Total, let us say. So total distance is how much? 400 kilometers. Time taken 3 hours plus 2 hours. Total time taken is 5 hours. So it is a 5. So this will be 5 8 is a 40, 0. So 80 kilometer per hour. 80 kilometer per hour. Now this is the first one, average speed. Now second one, they are asking average velocity. Average velocity. So if you want to calculate the average velocity, children, the formula is total displacement by total time taken. But the question is that the train is going from A to B, again coming back to the point A only. So if any object comes back to its initial position, the displacement is 0. So children, whenever displacement is 0, there is no velocity, we can say that. Okay, na? So as a total displacement is 0, so what will happen? Average velocity is equal to 0 by total time taken. So this will be 0 only. Okay, children. So you should be very, very careful whenever we are talking about the velocity. As a velocity vector quantity, you must be very careful. So in this case, the total displacement is 0, hence average velocity will be 0. So in the 8th numerical, it is given that, children, so a car is going towards the east such that it covers 100 kilo, it is given that 1 kilometer, let us say 1 kilometers in east direction in 100 seconds. Now they are asking us to calculate the velocity of the car and the speed of the car here. So first let us take a speed. Children, we know that speed is equal to distance by time. Distance by time taken here. Distance is 1 kilometer, okay, and speed time is 100 seconds. So kilometer let us convert into meters, that is 1000 meters by 100 seconds. So 2 zeros cancel. So speed is equal to 10 meter per second. But children, how to calculate the velocity? Children, the magnitude of the speed and the magnitude of the velocity is same. Am I right? So velocity is equal to 10 meter per second only. Then you may get a one doubt, sir, what makes the difference here? Children, as a velocity is a vector quantity, we should give a direction. So 10 meter per second due east. So it is moving, means it has the direction of velocity is in the direction of east only. That is what we have to make it. Okay, now fine. Next. So in 9th one it is given that a car starts from rest. So any object is starting from rest, then its initial velocity will be 0. And it is given that in a 2 seconds, children, it acquires a velocity of 10 meter per second. 10 meter per second. Now, so as there is a change in velocity, obviously car has some acceleration. So they are asking us to calculate the acceleration. Okay, na? So here acceleration formula is v minus u by t. Let us substitute here 10 minus 0 by 2. This is 10 by 2. It is 5. So acceleration is equal to 5. But units are very important. That is meter per second square. So this is how, whenever velocities and times are given, directly we can use a is equal to v minus by 2. Why? Because acceleration is equal to change in velocity by time. So whenever there is a change in velocity, then only acceleration will be there. If a body is going with a uniform velocity, what will be the acceleration? Zero acceleration. Okay, children, copy it. So find the acceleration. Children, these three numericals, even next numerical also similar based on the acceleration only. So in a numerical 10, if you can see, a car is starting from rest, so initial velocity is 0, and it acquires so this much velocity in this much time, but time is given in hours, we convert it into seconds. Now let us calculate the change in acceleration, that is v minus u by t. So this will be 180 minus 0 by 180. So if you can see, 180 minus 0 will be 180, 180 by 180 will be 1. So it is 1 meter per second square. Okay, fine. And 11th question, the body is going vertical upwards. So whenever the body is going vertical upwards, due to the gravitational force, children, its velocity keeps on decreasing. So at a certain point of time, the body is thrown with a 30 meter per second. After 3 seconds, its velocity will be v. Then calculate the acceleration. So acceleration is equal to v minus u by t here. So this is 20 minus 30 by 3. So this is given minus 10 by 3. So acceleration is equal to, if you can see, it is minus 3.3 meter per second square, children. So here why we got a minus? Because the body is retarded. Whenever the body velocity is decreasing, we can say that it is getting retarded. So we will get a minus value for acceleration. That only we can call it a deceleration or retardation also. Okay, fine. Now come to the 12th question. In this, a toy car initially is moving with 18 km per hour, and after 2 seconds it is brought to rest. So after 2 seconds it is brought to rest means what? The car is stopped. So its final velocity is 0. And an important point is that here it is given kilometer per hour, just we converted into meter per second. Now look at here. So acceleration is equal to v minus u by t. So which is equal to the 0 minus 5 by 2. This will be minus 5 by 2. So acceleration is equal to minus 2.5 meter per second square. So here also we got a negative value. Why? Because initially it has velocity 5, then 0. So velocity is decreasing. Whenever velocity decreases, children, we will get a negative value for acceleration. Is it clear? Don't get confused. Okay. And here some students will do one mistake here. They will write retardation is equal to minus 2.5, or else deceleration is equal to minus 2.5. No, you cannot write like that. If you want to write a retardation, then retardation is just 2.5 meter per second square only. deceleration is equal to 2.5 meter per second square only. There, because retardation itself is a negative acceleration. Deceleration is itself is a negative acceleration. Okay, na? Just copy it. Yeah, children, actually in this question it is given actually 50 meter per second. No problem. Just I changed the number so that we got that answer. But actually according to textbook, the 50 meter per second. Then this is going to be 50. Then this you will get a 30. Then here you will get a minus 10 meter per second square. Here nothing is wrong. So according to the value what I have taken, with that I calculated. Okay, na? Just because in an exam also don't expect the same numbers, whatever is given in the textbook. That number might be changed. So previously what I took what I got minus 3.3, it is according to the number speed which I have taken. Now this is minus 10 meter per second square is the answer according to the textbook value it is. Okay, na? Copy it. What will be its final velocity? Children, as per the question 13, so a car is accelerating with a 5 meter per second square. Then what will be its, as it is accelerating, obviously its velocity is increasing. So what is the increase in its velocity after 2 seconds? So children, increase in velocity means what? They are asking us to calculate V minus U. Increase in velocity, there is a change in velocity. So we know that here A is equal to V minus U by T. So increase in velocity is equal to A into T. Acceleration is equal to 5, time is 2. So this will be 10 meter per second. That's it. Very simple. Now in a 14th question, if you can see, a car is initially moving with a 10 meter per second. Then brakes are applied. Children, when the brakes are applied, don't expect that immediately car will come to the rest. So its value, its velocity keeps on decreasing. Means what? The car is moved the retardation. That's what here it is given a negative value. Then after 2 seconds, then what will be its velocity? Whether the car will be stopped or still it has some velocity. Look at here. So A is equal to V minus U by T. So here V minus U is equal to A into T. Take this A this side, so T this side. So then V is equal to AT plus U. Okay, children. Now you substitute the value. A value at any cost you must substitute with the negative sign only because of the retardation. So minus 2 into 2 plus it is 20. This will be minus 4 plus 20. This is V is equal to 16 meter per second. I mean what? So after 2 seconds, if it is moving with this much retardation, its velocity will be 16 meter per second. Okay, now fine. Now come to the 15th one. A bicycle initially going with a 5 meter per second. If it accelerates at a rate of 2 meter per second square, then what is its final velocity after 2 seconds? So same formula we can use here directly. We can use, let us here also. So V is equal to AT plus U. So this is 2 into 5 plus 5. So this is 10 plus 5. So this will be 15 meter per second. Okay, children. So this is how we have to. Children, this is not a new formula actually. Try to understand. Actually, the in a next unit, so it's one of the first equation of motion actually. But this we got from here only. A is equal to V minus U by T. Okay, children. Just copy it. If for suppose if it is like after 5 seconds as per the textbook. So here you should take a into 5. Okay, na? Then it will become minus 10. Then it will become plus 10. Okay, children. Is that clear? So just when you change the number, answer is means in exam you should not try. In exam, if a numerical is given with a certain data, you don't change according to you actually. Okay, na? Just while I was writing a data, just I forgot. Instead of 2 seconds, I wrote 5 seconds. That's it. Today something I'm writing something, but mind is thinking some other thing. That's what I wanted to write something, but some other thing I'm writing. But you should be very careful. Okay, na? Just how much, children? In this question, it is given that a car is moving with 18 km per hour and finally it is brought to the rest after 5 seconds. So the first question is that they are asking us to express what we get the speed value in terms of meter per second. So it is given V is equal to 18 km per hour. Children, we know that 1 km per hour is equal to 5 by 18 meter per second. 18 gets cancelled. The answer is 5 meter per second. Okay, fine. Now second one, as a car velocity is decreasing, speed is decreasing because straight line motion. So definitely it is moving the retardation. They are asking us to calculate the retardation. So A is equal to V minus U by T. Children, for retardation we don't have any special formula. Use the same formula, but we are sure that we are going to get a negative value. So because it is a 0, minus 5 and 5. So this will be minus 5 by 5. So A is equal to minus meter per second square. Okay, fine. And here third one, if you can see, after 2 seconds what is its final velocity. So after 5 seconds it is brought to rest, but not after 2 seconds. After 2 seconds still it has some velocity. So V is equal to, directly let us use U plus AT. So in a previous question we discussed how we got this. So U value is 5 plus minus 1 into 2. So this will be 5 minus 2. So this will be 3 meter per second. So children, this is how actually we can calculate the velocity of the car or velocity of the body after some time actually. Okay na? So children, with this we successfully completed the numericals from exercise 2A. Children, once again I am telling you, so whenever you want to prepare any chapter, so textbook is the ultimate source for you. Read the textbook. When you are reading the textbook, please make your own notes. After making your own notes, then go through the example questions, might be theory questions or numericals. Solve those questions and try to solve the exercise questions even given. First example questions, then exercise questions. There you have a doubt, anything. So you need to refer like a videos. So it might be our video, our channel video, some other video. It's not that, children, here. So we are not forcing you to come back to our video only and to watch it. It's not that. Whatever you feel comfort, whatever you feel that yes, that particular channel will help you out to become a strong in that particular subject. Is that clear, children? So again, I'm telling you, read the textbook. Okay, children. Thank you so much. All the very best.